Okay, so how is everyone today? Good, I hope. Good-ish. Dry, hopefully. Okay, so last time we were talking about inequalities. And just to go over a few things. As a reminder, inequalities are something that you were familiarized with before you got to this class. So we'll work under those assumptions, but we're using them in a slightly more rigorous way than before. So this statement right here is read aloud as 13 less than 14. And this kind of statement is an inequality. And inequalities, when evaluated, have a logical value. What is the logical value of this inequality? True. Good. So here's another inequality. 2018 less than 1314. So in the first place, is this an inequality? Yes. What is its logical value? False. Okay. And, you know, for those of you who never were entirely sure about the way these work, I'll just admit to you that in my head it works like this. The way that you know that it's correct is that I put little, either literally or just in my imagination, put little eyeballs on it and remember that the alligator eats the bigger number. That's how you know that it is true. If it were the other way around, it'd be false. Good. Last time we also talked about operations on inequalities, because in the end, just like equations, and you want to solve equations with inequalities, you want to solve inequalities. So you've got to perform operations on them, and you have to know, in the first place, how those operations work, and in the second place, when they're permitted. So it is always permissible to add the same thing to both sides. That's always okay. Or subtract. This is also okay. You can do that without any concern that you're going to modify the logical value. If it was true to begin with, it will be true in the end. If it was false to begin with, it will be false in the end. Is it permissible to multiply both sides by something?
Positive.
Okay, so 0 is not going to work. You can't do that. But you can do it with positive numbers, and in that sense, it's just like equations. But what about negative numbers? You can do that as long as you remember that to preserve the logical value, you must reverse the direction of the inequality. Less thans become greater thans become less thans, etc. Okay. So here's an example exercise. Please solve. How about 2 less than or equal to, I don't know, 4x plus 5 less than 10. So inequalities are in some sense more interesting than equations, because with equations, when you write them down, there's just 2 positions that we refer to as the left-hand side and the right-hand side. But this one, you can see that there's 3 positions, right? The left, and the middle, and the right. And in principle, I could do any number of things, right? I could do like this thing, less or equal that thing, less than that thing, less or equal that thing, all the way down the line. This means, so just as an aside, this means you take the 2 positions in sequential pairs. So the first 2. This means 2 has to be less or equal to 4x plus 5. So that's just taking the first 2. But you also need to take the second 2. So this one and that one. So 4x plus 5 less than 10. And what the interpretation is that both of these must be true. So it's that one is true, and that one is true. So you might say, well, if that's what it means, then why do we write it that way? You know, if this is what it actually means, then why write it this way? And the answer is shorter, right? So if we had that inequality, so 2 less or equal 4x plus 5 less than 10, its meaning gives you a hint on how to proceed. What if we were just dealing with this inequality? That is to say, I'm covering up this part and just looking at this. What would we want to do? Subtract 5. To get the x by itself, we'd want to subtract 5. What if we were dealing with just that inequality? What would we want to do? Subtract 5. And because those are the only two things, in a sense, looking at it that way and looking at it that way, and because in both cases we want to subtract 5, that's what we're going to do. But instead of subtracting 5 from both sides, we're going to subtract 5 from all positions. So subtract 5 from the left position, subtract 5 from the middle position, and subtract 5 from the right position. And now I'm having a faint memory of when something's negative, we're supposed to flip the direction. But it's negative.
But we're not dividing.
But we're not multiplying or dividing, right? When you subtract, in the first place, subtraction is always permissible, and in the second place, it doesn't reverse the direction of the inequality. So the left position is -3, the middle position is 4x, and the right position is 5. Okay. Now what? Divide by 4. For similar reasons. Because if it was just that inequality, we'd want to divide by 4. And if it was just that inequality, we'd want to divide by 4. As a result, so will we need to flip the direction? No. So -3/4 less or equal to just x less than 5/4. Okay, so then in such an exercise, the prompt will always be, obviously show all of your work and give me your answer in 3 forms. What are the names of those 3 forms? And plot. Right, so interval notation, algebraic notation, and plot notation. Of the 3, this is one of them. Which one is this? This is algebraic. Okay, so how do we do it as a plot? Okay, little bit of number line there. So, I already drew it. Should it be solid or open? Solid. Solid. Okay, good. Okay, and then to 5/4, and should it be solid or open? Open, good. Okay, that's the plot. So this is algebraic, this is the plot, and then as an interval, square bracket at -3/4, and then parentheses at 5/4. Any question about this one? This is okay? Okay. So let's do another one. But I'm going to put, in fact, I'm going to do just a little mini exercise right here. Suppose that we had this equation and the request was to solve. Say something like 2 minus 4w over 7 equal 8. So this is an equation now. What do you need to do? Right. If we wanted to isolate w, if we wanted to get w by itself, the first order of business would be to multiply by 7. The reason is because if you were to write this left-hand side in a straight line, if what I'm saying is that you know, this is like one thing and then a big division thing over 7. What if you wanted to write it all in a straight line? How do you write this in a line?
2 minus 4W.
Uh-huh. So it would be 2 minus 4W. Correct. And then a division. Or multiply by 1 over 7 if you like. So you could write it like that. So W's in there, right? W can't come out to play until you handle the 7. Okay, so then how do you handle the 7? By multiplying both sides by 7, right? That's how you undo division by 7. Okay, so I won't take it any further. So now here's a question. Please solve negative, I don't know, 6 less than 2 minus 4W over 7 less than 8. So what do we need to do? Multiply by 7, right? Because if we were solving just that inequality, the first order of business would be to multiply both sides by 7. And if we were solving just that inequality, the first order of business would again be to multiply both sides by 7. So we're going to multiply all positions by 7. Of course, the purpose, right, is to get rid of that over 7 in the middle. So the new left position is negative 42. The new middle position is 2 minus 4W. And the new right position is 56. All right, now what? Subtract 2. Subtract 2. Good. The reason is because, again, if it were this, we'd want to subtract 2, and if it were that, we'd want to subtract 2. So subtract 2 from all positions. So the left position is negative 44, the middle position is negative 4W, and the right position is 54. All right. Now what? Divide by negative 4 for similar reasons. So we're going to divide by negative 4 all positions. That's what we're going to do. So just dealing with the positions for a moment, the left position will be negative 44 over negative 4. The middle position will be just W, because that was the point of dividing by negative 4. And the right position will be 54 over negative 4. Then what semi-surprising bookkeeping issue also comes up?
Divided by negative 4. Sign ratio.
What do you mean signs?
Inequality.
Okay, good. If the inequality were just this one, if we were just doing this, then to make it right, to go from here to here, well, we'd have to flip that one. Okay? So, as a result, that one gets flipped. Similarly, if it were just this inequality, we'd still want to divide by negative 4, and to move from this position to that position, we want to, we're going to need to flip it. So this one goes that way.
And the note that I write out to the side is because we're dividing by negative 4, sign flips.
Right, something like that. Okay, then carrying out the arithmetic, the left position is 11, the middle position is W, And the right position is, what would that be? 10 of them, what is it? 27 over 2. Okay, good. So negative 13 and a half. Negative 27 over 2 is fine. It's fine. Notice how it would read if you had forgotten. Which is to say, what if you had forgotten to flip the direction of the inequality? It would read something like this. 11 less than W less than negative 13.5. Is it really the case that 11 is less than negative 13.5? Nah, that's not true, right? Yes?
Algebraically, is the way that we had to correct it, would you change it to where negative 13 was on the left?
This is fine.
Okay.
This is fine, yeah. I mean, there's two separate symbols. There's the less than and there's also the greater than. So maybe you're asking, is it permissible for you to reorder it and use less than instead? Just as fine. Yes? When you divide an inequality by a negative amount or multiply by a negative amount, so we're taking this inequality right here and dividing by negative 4 to get W by itself. As a result, if that were a 4, then we'd want to divide by 4, and in that case you would not reverse. The reason for the reversal of the direction is because we're dividing by a negative. Same. So this is the algebraic answer, but I'm always going to ask for all three. So I'll make the plot answer now. I'll offer a plot answer. So in the first place, I can see that because they're not less or equal or greater or equal, none of the or equal kind, they should both be open. So I can see that much. So here's the plot answer: 11 to negative 13.5. Right? Okay, good. So this is incorrect. I agree. So that's not right. Rather, it should look like this. Similarly, the interval notation is negative 13. Oops, what am I doing? 13.5. To 11.
I'm noticing on your plot
Mm-hmm.
that when you don't have the arrows on the outsides,
Mm-hmm.
you don't have to shade
Right.
in the,
Right. I mean, you could. Not to put words in your mouth, but I think that what you're saying is this: if you wanted to do like, this is a line segment, a piece of it. But if you wanted to show where it is on the whole shebang, then you could indicate it like so. You could say, well, here's a negative 13.5. Oh, how did that happen? Negative 13.5 and 11. But this is, as it's currently written, it's ambiguous. What do you mean by that? So to make it clear, you've got to like demarcate, like, oh, that's the part I'm talking about. Yes?
So would you prefer like the line segment versus the like, shaded in region, or
Either one's fine. Other questions? Putting it on a line segment is particularly helpful anytime you're going to do like operations with them. Like if you're going to do intersections and unions and things like that, it's a good idea to put them on a number line so you can see where they are with respect to each other. But if it's just like that, it's fine.
I had a really hard grader on one of my take off the point from not being very clear about where things should be. Like,
Mhm.
I'm just kidding.
Oh, you're talking about me. Okay.
Is the square, I mean, like, in terms of indicating,
Yeah.
like on these guys, I've never put a square around it to indicate there's my 3 answers. Is that okay?
Oh, you mean
Yeah, demarcated it with that square. I mean, I'll be okay not demarcating it like that.
well, okay. Here's the thing. So, a couple matters. So, in the first place, the overriding concern in let's back up even further. There's a shirt that I might even start wearing it to class, and the shirt says something on it. It says something like, "Yet another day went by, and I didn't use any algebra." And I'm gonna start wearing it to lecture. Well, that's sort of like, on the one hand, it's kind of, from my point of view, it's a little bit sad that such a T-shirt would exist. But on the other hand, well, it is to some extent true, right? Okay. Nevertheless, the state of Texas says that you can't have whatever degree you're seeking unless you take a course like this, even if you're not going to use algebra much, right? So then that raises the question, I hope, then why are we here? Right? If all of us are in agreement that in all likelihood, the vast majority of your days past your degree, you're not going to use algebra, then why are you here? The answer is because in order for society to function good, besides cooperating with each other, right, and not being jerks and things like that, you've got to be able to communicate effectively. So, and we also want you to be able to think clearly about a problem. So the reason why everyone is required to take algebra to get a degree is because it forces you to think clearly and to communicate clearly. That's why what's being graded is your work. So, as a result, if you respond to an exercise and your work is all over the place, well, that's not a good response. It's not a good response because, that would be like if someone asked you, how do you get to Walmart from here? And then you start talking about astrology. Like, okay, that's great, but I just need the answer to how to get to Walmart. And you give the steps in order, right? You don't say, well, in the 7th step you need to take is that, and then, well, let's talk about the 3rd step now. You've got to present it clearly. So I can appreciate that, there, in a sense, to this question, there's 3 different responses, because I'll ask for the algebraic part, the plot part, and the interval part. And in some sense, you might say, well, would it be permissible for me to write the plot part like up here and the interval part down there, and then they're all kind of all over the place? Well, that's less optimal than this one because it's less clear, if you take my meaning. So all I mean to say is we're all humans and therefore all lazy. That's something that we all have in common. Let's not mince words. Let's embrace it. But we also all have good judgment about if someone were to give me some instructions about baking a cake, or you give you instructions about baking a cake, I think you could use your own judgment to decide whether or not these instructions were organized neatly. It's the same exact thing here. Okay. Good. Let's move to the next thing. So, I'd like for you to recall that we have previously plotted the absolute value, and what is its characteristic shape? It'd be a V. Okay, so this is going to come up for the rest of the lecture. So here's an example. What if you were asked to solve this? The absolute value of 2x minus 7 is less or equal to 3. Okay. Now this is the first kind of exercise of this kind that we're solving. When you fully understand the ins and outs of this question, the response is about this long. It doesn't take long. But the discussion of why that is the way it is will take most of this page. So I'm going to write a big discussion here, and then the answer is just going to be a few like blip, blip, blip. But I think it's unlikely for you to understand why unless we have a discussion first. So let's consider a simpler problem. How about this one? The absolute value of w is less or equal to 3. So I claim that this problem is simpler just by virtue of the thing that's inside of the absolute value is a single item. Okay. So I'm going to refer to the left-hand side as the red. And the right-hand side as the green. And I'm going to split this inequality into two parts. The left part, I'm going to write y is absolute value of w in red. And then the part on the right, I'm going to write y is 3. And I've purposefully left some space here because I'm going to write something in there in a second. But while that's simmering, I'm going to draw pictures of these things. We just discussed that the shape of absolute value is a v. So, like so. So this would be y is absolute value of w. By the way, which axis is this one? The y-axis. And what's this axis? W. It's w because, well, those are the two things in this discussion. Fine. So the red looks like a v. The green, y equal 3, when you plot it, what does it look like? A horizontal line. And then is it above or below the origin? Well, there's the origin, so above it, right? So something like this. Okay. So we drew two things, the red thing and the green thing. And I can see that they're touching in two places, and that's often significant, and it is significant in this exercise. So in particular, I can see they're touching right there, and then if I come down to the w-axis, then that is some value of w. What value of w is that? In the first place, this you mean the right thing, but I don't want a point, I don't want a coordinate, I just want w. What is the w value? So in the first place, should this w be negative or positive?
Positive. W minus 0.
It should be a positive value because it's to the right of the origin. So what's its value? I claim that it has a numeric value that you can just tell me. 3. Why is it 3? Well, if y is 3, and y is the absolute value of w, right? It's 3. That's 3 right there. Has to be 3. I can see another place where red and green touch, right there, and then dropping down to the w-axis right there. What's that one? -3. Okay, so now what this inequality is saying is that this is saying red needs to be below or touching green. Red less than or equal to green. And because the increasing direction is up, that means we want red below green. So red is below or touching. Below or touching green. So I can see specifically that when W is 3, they're touching. What if we were a little bit further to the right, like at that place? So that might be like W is 5 or something. W is 5. There's the green value and the red value. So at W is 5. Is it the case that red is below or touching when W is 5? No, because you can see that red is above. So that 5 must not be what we're interested in. We're not interested in 5. What if we were here, like at 1? So that could be W is 1 right there. Is it the case that red is below or touching green? It is. So can you see that in the picture, some of the time, for some of the W's, red is below or touching the green, and for other W's, that's not the case. So can you see that it's all of these? So I'm going to say that the answer is the stuff that is between the 3's. Between the 3's, because there's 2 3's, right? There's 3 in the positive sense, and there's 3 in the negative sense. So the W's that we're looking for are the ones that are between the 3's. As a result, when you have an inequality like this, absolute value of W less than 3, the algebraic step that you can make to get rid of the absolute value. So we want to have another inequality that doesn't have absolute value. The way to do that is you say, oh, well, to drop the absolute value, you put it between the 3's. Okay. So the answer is this stuff. Because, if you like, I could ask, for this W, is it okay for me to, would it be true if I were to replace W with a 2.7? Would it be true? Yeah. What about a 3.0? Nah, it'd be false, right? Because it's 3 less than 3? Oh, it says less than, no, okay, so you're right. The problem is that when it says less or equal there, and then I did that. This should still be that. Okay, so now, if you put in a 3.0, will it be true? Yes? What about a 3.1? No. Okay, what about a negative 1.7? Yeah, that'd be okay. What about negative 2.99? Yeah, but how about like negative 3.01? No, that's not, that won't work. You've got to be between the 3's. Good. As a result, to answer the question that was originally posed, 2x minus 7 in absolute value less or equal to 3. How do we drop the absolute value? Because we want to get x by itself, but currently it's like trapped inside of the absolute value. Yeah?
That's a quick question about
Yeah.
that.
Yeah?
Is absolute value considered to be part of order of operations?
They're like, you can imagine them to be like parentheses, so that you can't smuggle the 7 out. It can't come out until you get rid of them. And the point of this remark is to show you what it takes. So we'd like another inequality that we could write, but there's no absolute value in it. So how do we do it? Right, because I want you to observe that this thing that we just wrote here, that's exactly what this is. Absolute value of something less or equal to 3. So I just need to write -3 on one side and +3 on the other side, and this thing that's inside of the absolute value in the middle, and don't write the absolute value. So -3 less or equal 2x subtract 7 less or equal 3. So this thing needs to be between the 3's. So now this one is just like ones on the previous page. As a result, I'll just race through it now because we've got lots of things to say. So we'll add 7, so 4 less or equal 2x less or equal 10. 2 less or equal x less or equal 5, so that the plot would be 2 to 5, and the interval would be 2 to 5. Beautiful. Lots of horizontal space in there. Okay. So how about this one? What if I ask you to solve, say, this one? Absolute value of 4z plus 3 greater than or equal to 2. So now, this exercise visually looks very similar to the previous one, but actually qualitatively it's going to be quite different. What's going to be different?
We're looking for the values that are above 2 in absolute value rather than below another.
Right. So comparing these two, notice that in the first one the alligator was eating the number, whereas in this one it's the other way around, right? Now this one is the alligator's eating the absolute value. Visually, I admit that it looks almost the same, but actually, it's the way that you solve it is markedly different. So, again, with a discussion. So, to consider a simpler problem, and remember, the discussion is not part of the answer. I'm trying to explain to you why the answer should be the way it is. So let's consider the problem absolute value of w greater than or equal to 2. And again, with the split. Considering the left-hand side, I'll make it red. And the right-hand side, make it green. So red and green, and then using the words red, green, below, and above, what do I need to write right here? We want red above or touching green, right? Red above or touching green. Again, the shape of absolute value is a V. And y equal 2 is, again, a horizontal line that is above the origin. There are, again, 2 places that they touch. Where do they touch? At what w value, I mean? 2. and negative 2. Now, we want it to be the case that red is above or touching green. So we've established that when W is 2, they're and negative 2. When W is negative 2 or 2, they're touching. So that must be part of the answer. Well, how about over here, like at 5? So that's right there is the value W is 5. Is it the case that red is above or touching green?
Yes.
Yes, because there's the red value. It's above the green value. So that's part of the solution. Similarly, well, how about right there, like at 1, at W is 1? Is it the case there that red is above or touching green? No. No, it's not. So over here, we have solution. Do we have solution anywhere else?
Yes, on the other side of the second.
On the other side of negative 2, right? Because back here, like at negative 6 maybe, at W is negative 6, you can see that again, red is above or touching green. So nothing between the 2's is part of the answer. So if conceptually I referred to the answer in the previous case as the stuff between the 2's, that wouldn't be right for this one. What would be a good way to say this one? It's not the stuff between the 2's. How about outside the 2's? Okay, that's good enough. All right, so this is the case of like outside the 2's. So it's the stuff over here and the stuff over here. The way you write this algebraically is like follows. So if you have absolute value of W greater than or equal to 2, then the way that you proceed and get rid of the absolute value is you actually must break it into 2 separate inequalities, which represent the 2 different pieces. There is the piece that is to the left of negative 2, and there is the piece that is to the right of positive 2. So W less or equal to negative 2, or W greater or equal to 2. 2 different possibilities corresponding to 2 different pieces. As a result, for the question that was asked, when you want to solve 4z plus 3 greater than or equal to 2. And again, just to look at it from an algebraic point of view, we want to put something in the absolute value so that the result would be greater than or equal to 2. Could you put a 1.5?
No.
No, that wouldn't work. That wouldn't be true. Could you put a 2.5? Yeah, 2.5 would work.
But could you put a negative 1?
Could you? Well, could you? What is the absolute value of negative 1.5?
1.5.
Positive 1.5. Is 1.5 greater than or equal to 2?
No.
It is not.
You could put a negative 2.5.
You could put a negative 2.5 or a negative 22.5. That corresponds to the 2 pieces, the piece on the right, the piece on the left. So the way that you proceed algebraically and dropping the absolute value is that you say, well, one possibility is that 4z plus 3 is to the left of negative 2. We're on the left piece. Or you might be on the right piece. So how do you algebraically write you could be on the right piece?
4z plus 3 is greater than positive 2.
Very good. So now we have 2 separate inequalities. And you just solve them separately. So subtract 3. 4z less or equal to negative 5, or 4z greater or equal negative 1. Z less or equal negative 1.25. or z greater or equal negative 0.25. So that's the algebraic answer. You have a question?
How do you combine the thing like w minus 2 less than equal greater than equal to 2 w and w greater than equal to 2 like in one equation?
You cannot. So let me finish writing it, and then I'll answer your question. So this is the algebraic answer. How do you write it as a plot?
We've kind of already done it, right?
Kind of, but I want to specifically the answer here. So how do you plot it? I don't mean this. I mean the number line bit.
Yeah, and I just meant the W line is effectively the same.
Right.
It's the same, right?
I agree, but how do we draw it with z's?
Negative 1.25 on the left. No, wait. Yes.
Okay, so
Infinity.
negative 1.25.
So
Oh,
to the
but
left.
z has to be to the left of negative 1.25, right, for the first part?
Okay, so
So negative 1.25 would be on the right, and then z would be on the left.
okay, so I could draw like this, and then
Wouldn't you have to put z on the other, like if that's the line segment?
mm-hmm.
You wouldn't put the z where you put the arrow?
I don't take your meaning. I'm not sure I understand what you mean.
Like, would it be?
Oh, you okay? You don't for the picture. You don't have to write a variable. I think is what. So I mean, like for example, in this picture, I didn't write any w's. So that's the left piece, and then the right piece is right, and then what? To the right. Two separate pieces. So then now how do you write this in interval notation? Mm-hmm. Mm-hmm. Okay. So then I'll raise the question: is it possible to simplify this? I mean, previously in the semester we dealt with intervals and the algebra on intervals, unions and intersections, and you were requested to simplify and things like that. Is it possible to simplify this?
No, because it has to stop. Like, there's nothing in between.
Right. They have to overlap,
Yeah.
in a sense. But these are two separate pieces. They don't overlap, so it's not possible to express this more simply. So, to your question, do you agree that these are two separate pieces? Do you agree that it is not possible to simplify this? It is also not permissible for you to write this as a single algebraic expression for those exact reasons. Now, so the answer to the question is this. These are the three styles of answer, algebraic and whatever. Specifically to yours, not to put words in your mouth, but I think you might have been asking for the following. You could say, you were asking for one of the following, that negative 1.25 less or equal to z less or equal to negative 0.25. So in the first place, is this correct? No, right? That's all the stuff between these. So that's not right. So that couldn't possibly be right, because this would be the between stuff. And we didn't want the between stuff, we wanted the outside stuff. So that's not right. And then you might say, okay, well, let's write it like this. Negative 0.25 less or equal z less or equal negative 1.25. Maybe that's right. But this is nonsense, because it is not the case that this number is to the left of that number. So this is just wrong, right? Well, it's not wrong. Well, as a response to this exercise, it's wrong. But this question is this statement is false for all values of z, because there is no z that is simultaneously both of those things. So this is, I'll just write a question mark. Okay, last thing. Let's consider these two possibilities. And these two are so easy that they're difficult, if you take my meaning. So please solve 5x plus 1 in absolute value less or equal to -8. And 2, please solve absolute value of 2w minus 5 greater than or equal to -4.
First one is no solution.
Okay.
Because,
But wait, the alligator's eating the thing, right?
yeah, but there's still no absolute value in the yield. Gives a
By
negative number.
virtue of the absolute value, it's like the distance
Mhm.
on the number line
Mhm.
becomes 0, and you can't have a negative distance.
I agree entirely. So, to say it and I agree with what you said, and to say it another way, what could you put in the absolute value so that what comes out would be less or equal to -8? Nothing, right? To say it another way, again, the shape of absolute value is v, and the shape of y equal -8 is also a horizontal line, but now where is it situated? Below the origin. And now my question is, where is red? Calling this one the red one. Does this one mean below or above? Below, right? Red, below, green. So where is red below green in this picture? Nowhere. Nowhere. As a result, the answer to this exercise is that there is no solution. How about this one? All reals. Because now you're asking, what could you put into the absolute value so that something more than -4 would come out? Anything whatsoever, right? So now the picture is the same, more or less, but the question is different. Yeah, I'm sorry, we're running like 90 seconds over. What's the question now? The question here was red below green. Now the question is, where is red above green? So red above green. And the answer now is everywhere. So the answer is all reals. So now, the reason why I say this is because, well, what's going to happen obviously is I'm going to make some homework assignments, and some students are going to respond to a question like this and say it's everything between the eighths because they don't understand the concept. That would be the case if the green line were above the origin, but it's below. Okay, so have a nice Wednesday.